Okay, this will be the explanation of the chess example, the 2D chess example. So let's take a look at the scene first. This is not perfect, you'll see in a second why, but when you click a piece, you see the possible squares where you can move that piece. Um, so as you can see, it is working. The black ones work as well. You can also take pieces, but not the king. If I go, actually, let me see. So you can take pieces, and when the pawn reaches the end, it is automatically converted to a queen. So if I take this piece, I cannot take the king. But there is only one issue with this, which is at the moment you can take pieces with the king even though they are not protected. That's the only issue with this. So how does this work? We have two main elements here. We have on each square we place a prefab with a collider, which I call a holder. So this one here. So it's just a collider that's the exact size of a square. It's triggers are no physics enabled and it has a script on it which let us know if there is a piece on top of it. So this is empty bool, or if it is the end, because when the pawn reaches the end, we want to convert it to a queen. Also, it has a sprite renderer because as you previously saw, when you click a piece, you can see the possible holders where you can move that piece. As you can see. Um, so that's one element, and the other one the pieces, and these are the pieces also have a collider on them. So if I go here to the board, let's say the white king, for example, it has a collider that's also the exact size of a square. Uh, but the thing is, we have a physics layer for the pieces and a physics layer for the holders. And also each piece has some children which represent the positions where you can place that piece. Um, so let's look at the algorithm. Uh, let's see. It's a bit complicated. I won't go through each line of code, but I'll explain the logic. So in the update function, well, actually in the start function, we spawn those holders. Uh, so we place a holder on each square of the board. So I have a function here that does that. So in other words, I'll actually go to this. So for each line and then for each column, we spawn a holder. And also, if those holders are the first or last two lines in the board, then that means at the start this needs to be occupied. So we say is empty is false because there are pieces on top of those lines. And also if not, then those are empty. Also we want to know the lines that are the end. So when a pawn reaches the end, we can convert it to a queen. So line 0 and line 8, those holders on those lines will have the isEnd bool true. So after we have that, let's look at the controls. So we have two cases: we either have a piece or we do not have a piece. Uh, if we do have a piece, we when we click, we raycast to the mouse position and only target the holders, and then we check if we clicked on a holder. Um, well, the first thing we do is we find the possible holders where we can move the piece, and for that we have a function here that finds all the holders where we can move the piece, the selected piece, and the algorithm are different depending on the type of the piece. So we look at couple cases here. So we have the first case here is the pawn. So in the beginning can move forward 1 square or 2 squares. Now let's look at the code 1 second. Well, if we also the pieces have a script, so we know the type of the piece. We know if it's white or black, and we also know if it moved once. So here we check if it moved once, because if it did move once, we can now move it forward only 1 square. So if it did not move 1 square, we can then move it 2 squares at the start. Else we can only move it 1 square. So what we do is we use the overlap point function. So what this does is creates a point at a specific position, and it checks if there is a collider at that point that overlaps with a point. So this part here is for detecting the empty squares in front of the pawn. So we go for int from 0 to 1. So the 2 squares forward. And then if there is a holder there, we check if it is empty. If it is empty, we add it to our list of possible holders. But we do this here for 2 squares if it's the piece did not move once. If it did move once, we only look at the first square in front of the pawn. So that's for forward movement. For diagonal movement, we have we check diagonally and see if there is an empty, that either is an empty holder, or there is a piece on the holder but it is of a color different than our piece. So that's for the pawn. For the rook and bishop, it's a bit different. So the way these positions here that are children of the pieces are arranged is kind of like this. This is the okay, the size of this. One sec, I'm sorry. Well, we can actually use text. So that's actually, wait. Oh, here it is, my bad. So let's say that's position, that's the first child, that's the second. So it's something like this. So the algorithm, what it does is goes for each line. So for the bishop, we have 4 lines. So something like this. So the way the algorithm works, it goes square by square, and if the square is empty, it adds it to the list. And then if it reaches a square that has a piece, let's say we have a piece here on the 4th one, then it checks if this piece here is a different color than the piece that we selected. And in that case, we stop adding holders here, because we obviously we cannot go through pieces with the bishop. So that's how this. Also, you cannot target the king. So if that piece happens to be the king, we don't add that holder to the possible holder. This algorithm works the same for the queen, but for the queen we have multiple. We have four more lines like this. The same logic, but with 4 more lines. Also, the rook works the same way. And now for the king and the knight, the logic is a bit simpler, because in this case we don't care about going through pieces. So let's say this is the king, the green square here. We just check for all the positions that are children of the king. And if there's the square is empty, we add it, and if there is a piece, we check if that piece is of an opposite, of a different color, and also is not the king, and then we add that to the list. Same for the knight. It's the exact same logic. So we have a function that finds the possible holders for the selected piece. So once we have that, when we click, we use the overlap point function. So let's go here. We use the overlap point function at the mouse position. If we hit something, we check if that holder is within the list of the possible holders. In that case, we can move the piece. So what we do is now we overlap point again below our piece, our selected piece. And because we move it, now that holder that is below the piece, the selected piece, is now true. And then it's time to move the piece, and if it's necessary, we destroy the piece that's on the square where we're trying to move our selected piece, and we make that now occupied. So 1 second, yeah. So here we recasted where we want to move the piece. We overlap point, and we're trying to see the piece on that holder. If there is a piece, we destroy it. And then we move the piece. We say the selected piece moves to that holder. Now it moved once. So that's only useful for the pawns. We know they move once. Now that holder where we move the piece is now not empty. And then if the selected piece is a pawn and it reach the end, so if the target holder is the end and the piece is a pawn, we depending on what color it is, we spawn either a white queen or a black queen, and then we destroy that pawn. And then if we do not hit when we overlap point at the mouse position, if we do not hit anything, so there is no holder, or there is a holder, but it is not within the list of possible holders, then we deselect the piece and we disable the sprite renderer on those holders. So that's for when we have a piece selected. If we do not have a piece selected, we check for mouse, for the left click, we overlap points at the mouse position, and then we just say that the selected piece is now the piece where we overlap point, and then we say possible holders equal find possible holders. So we find the possible holders, and then we enable the visual effect of the holder. On the possible holders, we enable the sprite renderer. So that's the chess example. It's a bit complicated. I might return to it in the future to explain it better.